All right, another one. That's right, part 3 of 2.09. If you know the atomic mass of each isotope and the relative abundance of each isotope, you can determine the average atomic mass of the element. An atom of lead has 4 naturally occurring isotopes as outlined in the table. Using the same formula that you used for potassium, it is possible to calculate the average atomic mass of one atom of lead. So, as always, lead has 82 protons. The number of neutrons vary, and that's what gives us the isotopes. Again, the numbers up here are the mass number. So 82 plus 122 is 204. Then what percentage of the abundance? So 1% is lead 204 versus 52% is lead 208. And then it gives the exact atomic mass. All right, so hit the pause button. Try and do this one on your own. Collect our information. We changed all of our percents into decimals by dividing by 100 or moving the decimal 2 places to the left, and then we wrote down the mass. So percent as a decimal and the mass. Percent as a decimal and the mass. Percent as a decimal and the mass. All right, put her in. Again, percent times mass plus percent times mass plus percent times mass plus percent times mass. Okay, it's always the same pattern. All right, and if you'd like, you can hit pause and read that paragraph. Put in your numbers. Again, percent times mass plus percent times mass plus percent times mass plus percent times mass equals 207.22. And the average atomic mass of lead is 207.22 AMU. So let's look at that makes sense. Well, we have just a couple of the really tiny ones. We have a lot of the really heavy ones and kind of an even amount of the middle ones. So overall, since over half of them are 208, that makes sense that the average would be more than 207 because less than half have a mass of less than 208, a little more than half have a mass of 208, but that puts the average kind of right in here. Again, it's a weighted average. The isotopes of an atom have the same number of protons but different number of neutrons. Most elements have 2 or more isotopes. An isotope is a different form of the same atom of that element. It just has extra neutrons. By definition, an atom of any element has a set number of protons. It is the number of neutrons within the atoms that varies, and that's what makes it an isotope. Each isotope has a different atomic mass, and each occurs in nature in a different abundance, so it's not even amounts of all of them. Understanding these simple facts can make it possible to calculate the average atomic mass of a sample of that element. Types of atoms, isotopes. Examples, instead of the normal carbon-12, we have carbon-13 because it has an extra neutron. Instead of uranium-235, this isotope is uranium-238 with 3 more neutrons. And isotopes averaging results in the average atomic mass.